In this session today, I would like to discuss with you few questions and numericals. The basis of this numericals would be gravitation part 1 and part 2. I mean universal law of gravitation. You must have watched, and so now let's do few questions. In the first part of the question, it's a very basic question that I would like to discuss with you, that the two objects, these are the two objects of mass say 20 kg and 40 kg, and they are separated by a distance of, let's say, 20 centimeter. So what is the force of gravitation between these two objects, and what is the acceleration produced in each object, this and this, because of this force? Let's see. Here I consider two objects. These are the two objects, right? And the mass of one is 40 kg and mass of another is 20 kg. Let's say you can assume any mass, 15 kg, 25 kg, 50 kg, 100 kg, कुछ भी हो सकता है. The distance between the centers of two objects, let's say it's 20 centimeter, close object. So this is M1, M2 and D, a basic formula. M1, M2 and D. So M1 is 40 kg, M2 is 20 kg, and distance between these two masses is 20 centimeter, right? So according to a universal law of gravitation, the force between them is given by, this is question 1, answer. The force between these two objects will be given by capital G, universal gravitational constant, this, M1, M2 over d square. Very simple, right? Now put the values, but before you put the values, before you substitute the values, see here M1 in kg, SI unit of mass is kg. This is also 20 kg. But you can see here the distance is given in centimeter, which is not perfect. We have to convert this centimeter into meter. So in any numericals, you must take care of unit conversion. That's very important. So 20 centimeter is equal to 20 by 100 meter, and that is equal to 0.2 meter. And that's the meter. Now all the data are perfect. Substitute the values. Very simple. G is 6.67 into 10 raised to the power minus 11. M1 is 40, M2 is 20, and D is 0.2 whole square. And now simple. Solve this. So F is equal to 6.67 into 10 raised to the power. I cut these two zeros with this. Now it's minus 9. I hope you understood. Minus 9 into 4 and 2, 8. Keep it 4 into 2. Divided by 0.2 into 0.2. First, I would remove these decimals. 6.67 into 10 raised to the power minus 9 into 8. Now for these two, this and this, you will write 10 into 10 means 100 here, divided by 2 into 2. That's simple. Now final F is equal to 6.67 into 10 raised to the power. Again we can cancel it like 7 minus 7 into 2422 into 2. See here, you get this simple multiplication now. So final answer is 7 Newton. You can make it more better, 1.33 into 10 to the power minus 6 Newton. So this is the answer. So you just have to write the basic equation of universal law of gravitation and then put the values. This is a straightforward question. Generally comes in the exam. But unit conversion, don't forget. Generally they give you that, they will try to confuse you that. They'll give you distance in centimeter and many students put centimeter and solve and get less marks. That was question number 1. Let's discuss question number 2. In this, I would like to first discuss with you the very basic concepts of vertical motion. In vertical motion, when an object is thrown upward, it is thrown with some initial velocity. So whenever an object is thrown, initial velocity is more than 0. And then object starts moving upward. And at the highest position, it stops for a moment and then starts moving down again, free fall. If you see here, object is thrown with some initial velocity, u. Initial velocity is u, right? And then object starts moving upward. Say this ball and start moving upward. Let's assume that this is the highest point this ball attained and then stops for a moment. It means final velocity is 0. So one point, when you throw an object upward, then it is thrown with some initial velocity. Initial velocity is not 0 in this case when you throw. At the highest position, object stops. So final velocity is 0 at the highest position, right? So V is 0 here. Now acceleration. What would be acceleration when object was moving upward? When object was moving upward, a downward force is continuously acting, and that is gravitational force. So gravitational force continuously pulls this object downward, and that's why object slows down and finally stops at the highest position. It means that when object moves upward, it's a retarding motion. It gets retarded because of gravitational pull of the earth. And so acceleration would be negative in this case. The J is, and you know that acceleration produced by gravitational force, whether it's positive or negative, that is called acceleration due to gravity. So acceleration, when object moves upward, acceleration will be negative always. So it's a retarding motion. When object reaches to the highest point, then it's a very important question. What is the acceleration at the highest point and what is the direction of acceleration? Acceleration at the highest point be still positive, non-zero, and downward direction, in downward direction. And you know that on the surface of the earth, the value of acceleration due to gravity is 9.8 meter per second square approximately. So that is minus 9.8 meter per second square, and here it's 9.8 meter per second square, downward direction. Acceleration, the direction of acceleration due to gravity is always downward, whether object moves upward or downward or at the highest position. The direction of acceleration due to gravity is always downward. And on the surface of the earth, its value is not zero. Even at the highest position, object stops for a moment, but acceleration due to gravity is 9.8 meter per second square in downward direction. Now object starts falling. During the fall, the initial velocity would be 0 because it falls from rest. It falls from rest, right? So initial velocity would be 0, right? Sorry. So initial velocity would be 0. Now object starts falling down here, and then it hits the ground with maximum velocity. So here we can find out V. After hitting the ground, it stops. So don't get confused that what will be final velocity. Final velocity is the velocity with which object hits the ground, and it is not 0, right? So that we can calculate. And numerically, that is equal to U. If it was thrown with 30 meter per second, then it will hit the ground. When it comes back to the ground, it will hit with 30 meter per second. Numerically, the time taken to go up is equal to the time taken to come down, and that is called time of ascent is equal to time of descent, but numerically. In numericals, you have to show that. We cannot take, suppose an object is thrown, it goes up, comes down, it took 10 seconds, so we cannot divide 10 by 2 is equal to 5 seconds to go up and 5 seconds to come down. Show it numerically, right? Okay, so that is the overall. During the downward motion, its acceleration is 9.8 meter per second square, positive. So this G is 9.8 meter per second square during downward motion. Now equation of motion, we can apply all the three equations of motion during upward and downward motion, means during vertical motion. So what is the equation of motion? The first equation of motion is here. We can write the first equation of motion is here. V is equal to U plus A into T. But here we will not use A, so we will write here G into T, right? Where V is final velocity, U is initial velocity, and G is acceleration and T is time. This is first equation of motion, and this would be negative for upward motion and positive for downward motion. The second equation of motion is H is equal to U into T plus 1 by 2 G T square. Again, what is H here? H is the maximum height attained by the object when it was thrown, right? So H is equal to U into T. U is initial velocity with which object was thrown, T is the time, and G is acceleration due to gravity. Again, when object moves up, G is negative. Third is square of final velocity is equal to square of initial velocity plus 2GH. It's equivalent to V square is equal to U square plus 2AS. These three equations we'll be using in the numericals. Second question in this comes that an object is dropped from height h. An object is dropped from height h, and the height is given, say, 25 centimeter, 25 meter. What is the velocity with which it hits the ground? Like this. It's a case of free fall. So you can take this example, like initial velocity would be 0 in this case, object falling, height is given here, and v we need to find out. We can use this equation, third equation of motion, like in this case v is the maximum velocity, you need to find out v, u is 0, g 9.8, or sometimes in question itself given that take the value of g 10. So if given, take 10, otherwise 9.8. Height is given here 20 meter, so 2 into 9.8 into 20 will give you the velocity of the object with which it hits the ground. Sometimes they give you time and they ask you calculate the height, calculate the initial velocity, final velocity, anything you can do. These are the three weapons for you, right? So equation of motion we can apply in gravitation as well. So let's see question now. Now let's do numericals based on vertical motion. I have one question here. An object is thrown vertically upwards and rises to a height of 10 meters. This is the object thrown vertically upward and this rises to a height of 10 meters. Right? Calculate the velocity with which the object was thrown. Initial velocity. You need to find out initial velocity and the time taken by the object to reach the highest point. This is the question. Simple question. When an object is thrown upward, its acceleration would be negative 9.8 meter per second square. That is for sure. U is not given. Height is given 10 meter. At the highest position, V will be what? 0. Stops. V is 0 here. Very simple. You need to find out U. Time is not given. It means we need to find out time as well. So two things we need to find out. Number one. Here. Velocity with which it was thrown and time. From this point, let's say this is point A and this is point B. From point A to point B, time taken to reach the highest point. Very simple. Which equation we can use here? When time is not given, then and height is given, then we can use this equation. Right? Third equation of motion. This one. So let's see how to solve this question. Using third equation of motion. Using third equation of motion, which is V square is equal to U square plus 2 into G into H. Now let's see. This is 0, 9.8, 10, easy. So V square is equal to 0. So 0, U square plus 2 into minus 9.8 into 10, and so 0 is equal to U square minus 196, 2 into 9.8, 19.6 and 10, 196, and so minus U square is equal to minus 196 minus gone, and U is equal to 14 meter per second. It means that the object was thrown with an initial velocity of 14 meter per second. Right? That's easy, na? 14 meter per second. Simple. Second part of the question, that is time. How to calculate time? Now we have got initial velocity. We have got initial velocity and we have got final velocity, which is 0. We have height. We need to find out time. Time you can find out either using this or this, but easier to use here equation of motion. That is also very intelligent decision, that which equation to use to minimize your time, because in the exam time is very less. So let's see here the second part. It's very simple, like V is equal to U plus A into T. This was first part. Second part, V is 0, U is 14 plus minus 9.8 into T, and so 14 is equal to minus 14, 9.8 into T. So time is equal to 14 divided by 9.8, which is equal to 140 divided by 9.8, 7, approximately 1.4 second it will take, right? You can find out just 1 or 2 places of decimal, probably 2 places of decimal is fine. And that is the answer of this question, easy. One student asked me question, I believe this is NCERT question. A stone is allowed to fall from the top of a tower, 100 meter height. A stone is allowed to fall from a tower of height 100 meter. Let's see. It's a tower. Let's say the height of the tower is 100 meter. 100 meter. A stone is allowed to fall from the top of a tower 100 meter height. 100 meter height. This is the stone which is allowed to fall from the 100 meter height tower. At the same time, another stone is projected vertically upward from the ground. Great. At the same time means time of drop and time of throw, these 2 times are same. At the same time, thrown, projected vertically upwards from the ground with a velocity of 25 meter per second. 25 meter per second, and the initial velocity of this object is 0 because this object is dropped from the tower. So initial velocity is 0 in this case. Right. Calculate when and where the 2 stones will meet. Great. Calculate when and where means at what time and at what height they will meet. This is the situation. This stone is dropped and another stone is thrown vertically upward, right? This is thrown with a velocity of 25 meter per second and this is dropped, so its initial velocity is 0. Now situation is like this. So time of meet will be same, because now we need to find out how much height, how much vertical height or distance they travel during this time interval. We don't know time. In this case, we have 2 frame equations. Let's say that the object meet at somewhere like this. At this point, this is the meeting point. This is the meeting point. Object fall, it goes up. This is the meeting point, right? And I just assume that this height is x, and so this height would be 100 minus x. Clear? It means this is x and this is 100 minus x, this distance. It means that in time t, let's say time t and time t, in time t from object this stone, first stone covers this height x. We don't know height. And in the same time interval, the second stone which was thrown at the same time covers from here to here. So this is the meeting point. We need to form equation for the free fall and equation for object moving upward. For this, and we can use here second equation of motion, right, which is h is equal to ut plus 1 by 2 gt square. For downward, this g is positive. And for upward, g is minus 9.8 meter per second square, right? So we'll see here. So we'll see here. H is equal to ut plus half gt square. H is x, u is 0. So u into t, 0 into t, 0, plus 1 by 2 gt square. It means that x is equal to 4.9 t square. Equation 1. 4.9 because g is 9.8. So 9.8 divided by 2, 4.9, and then t square. This is, let's say, equation 1. Now we will write the equation for part 2. Vertically upward. Here height is 100 minus x, which is equal to ut plus 1 by 2 gt square. So 100 minus x is equal to 25 into t. Initial velocity is given here, 25, right, into t, plus 1 by 2, 9.8 t square, correct? If you see here, we can solve this. 100 minus x is equal to 25t minus 4.9 t square, correct? If you see here, this part in equation 1, 4.9 t square, x is equal to 4.9 t square. It means that we can substitute 4.9 t square equal to x here. Like this value gives you x here. So substitute the value of 4.9 t square in equation 2. This is equation 2. Using (4.9 t square is equal to x in equation 2. We can write 100 minus x is equal to 25t minus x. Now equation is simple here, and in this case we can see this and this can be cancelled. So we have here 100 is equal to 25t, and so t is equal to 100 by 25, which is equal to 4 seconds. It means that after 4 seconds they will meet. The object here They will meet after 4 seconds. In 4 seconds, it will travel x and it will travel 100 minus 6. Now we will find, because we have got the time, we can put the value of t in any of the equation. Let's say I am putting the value of t in equation 1. Putting t is equal to 4 seconds in equation 1. So equation 1 is x is equal to 4.9 t square, which is equal to 4.9 into square of 4. So x is equal to 4.9 into 16. And so find out this height, and that will be the value is 78.4 meter. It means from the top they will meet at 78.4 meter, and from the bottom that is equal to, this is from the top. And from the bottom, 100 minus x is equal to 100 minus 78.4, and that is equal to 21.6 meter. So from the ground. From the ground. Now next question, one student asked, that is also from NCERT, that a ball is thrown up vertically, returns to the hands of the thrower after 6 seconds. Find the velocity with which it was thrown up, the maximum height it reaches, and its position after 4 seconds. That's easy question. A very simple question is this here. Let's see. An object is thrown vertically upward, and then it comes back to the hands of the thrower. Nothing is given. Just one thing is given, that it takes 6 seconds for the entire journey, and nothing is given. No height, even height is not given. Here, initial velocity would be, let's say, x, and this is final velocity, let's say, equal to, right here, final velocity we need to find out. We don't know. Height we don't know. So the first question is, calculate the initial velocity, means velocity with which it was thrown. Understood the question? An object is thrown vertically upward and comes back to the thrower. Means this is the situation. It goes up and comes back to me. Question is, with which velocity this was thrown? U, initial velocity. Very simple. Acceleration, in this case, very simple. One concept is very important in this, that when the object was thrown and comes back to the hands of the thrower, what is net displacement? 0. So here we'll write, let's say this is the displacement, which is 0. Net displacement is 0. Acceleration due to gravity is minus 9.8 meter per second square, because it was thrown, and so during going up it was retarding. And then we can use the second equation of motion, because time is given here, total time is given, so we consider total journey. We will not break the journey, we'll consider total journey. I think many students divide the time 6 by 2 and take 3 seconds and calculate this value. I believe that is not Very correct idea. Consider the entire journey comes back and net displacement is 0. Take the total time for this displacement and use the second equation of motion, you'll get the answer. Easy. See here, S is equal to ut plus half gt square. I took here S because I consider displacement, net displacement. I'm not calculating height, so I used here S. Net displacement is 0. Initial velocity we don't know. Total time is 6 seconds plus 1 by 2. And I'm taking G here. I'm taking 10. Right? You can take 9.8 in the exam if not given. And time is again 6 seconds. So a square of 6. So 0 is equal to 6 into u minus 5. 2 into 10 by 2 is 5. 36. And so minus 6u is equal to minus 36 into 5 is 180, minus gone. So u is equal to 180 divided by 6. So initial velocity is 30 meter per second. See how easy was it? No confusion. So it was thrown with a velocity of, so u is equal to 30 meter per second. That's quite easy. In the second part of the question, it's asked that maximum height it reaches. Now it's easy. Now you know the initial velocity, so use the third equation of motion and calculate the h. H is equal to, no, square of velocity is equal to initial velocity plus 2 into g into h. At the highest position, it stops and then starts falling down. So v is 0 at the highest position. Now we are considering only this part. We are not considering the second part of motion. We are considering object goes up and then stops here and then starts coming down. So stops here when it reaches the maximum height, and we are calculating maximum height. So we are considering here the motion till here. So v is equal to u, which is square of 30 minus 2 into 10 into h. So minus 900 is equal to 20 h. Minus cancel. So h is equal to 45 meter. Right? So it will travel maximum height of 45 meter. Simple. Now the third part of the question, that the position of the object after 4 seconds. Again we can consider here. Again we can consider this motion after 4 seconds. That's quite easy. Here, let's say that position, let the position after 4 seconds be x. Let the position after 4 seconds be d. Right? X. So we can use here second equation of motion, that is x is equal to ut plus 1 by 2 gt square. Here this is the position after 4 seconds, means time is 4 here. So x is equal to u, it was thrown with a velocity of 30 into 4 plus 1 by 2 into minus 9.8 into square of 4. Simple. That is equal to 120 minus, we are taking 10, right? So take 10 only, 80. 4 times 16, 5, 80, yeah. That is equal to 40 meter. So position after 4 seconds is, means, and we also calculate the time to reach the highest position, that is v is equal to u plus a into t. V is 0 at the highest position, u is 30 and plus minus 10 into t. So t is equal to 3 seconds. See here, very easy. The time to reach at the highest position is 3 seconds here. And time to fall. So in the first 3 seconds it will reach the highest position, and in the next 1 second, because it's asking you position after 4 seconds. So in the first 3 seconds it will reach the highest position, and in the next 1 second it starts falling down. Let's say this is the position after 1 second. It means that from the ground it will be 40 meter. After 4 seconds the position of the object would be 40 meter from the ground. That's it.